All right, ladies and gentlemen, thank you for flying about this beautiful day. Today is the 9th of June, 2015. All right, so what we want to do is spend a little bit of time reviewing, and we're going to go back and look at some work problems, which we have not completed. But first and foremost, steps to simplify, and in particular, make sure, I should actually put the word fractions there. Whenever you have fractions, you have to simplify in a certain way. Remember what a fraction is. A fraction, the fraction bar, simply means divide. Simply means divide. So the first thing we have to do is factor. And what does factor mean? Is turn it into a multiplication situation. Multiplication situation. 12 is 3 times 4. Or x squared minus 9 is x plus 3, x minus 3, etc. And lastly, we reduce. And what reduces? The common factors. We reduce the common factors. It's all about factors. In other words, it's all about multiplication. Number one, we have to factor anything and everything, or consider factors. And number two, we reduce them. So in problem number one here, notice that 3x is already in a factored form. It's 3 times x. Down here is not. How do I know it's not factored? Because there's a big fat plus right there. This is not factored form. So I'm going to rewrite, and the denominator can be factored using a GCF. What's the greatest common factor I can pull out? So I'm going to pull out a 3 here. And when I divide the 9x squared by 3, I get 3x squared. And when I divide the 3 by 3, I get a 1. So I bring plus 1. In other words, I'm undoing distributive property. Because if I distribute this 3 in, I'll get back here. Or undistribute. Factor and distribute. All right, now I can start to reduce. Notice the only factors that reduce here are the 3's. Why? How do I know I can do it? Because there's a times there and a times there. A multiplication there and a multiplication there. And this one has nothing else attached to it. All of this right here, this binomial, has the plus 1 attached to it. So all of this or none of this goes away. And now I can just write the remainder. The x is in the numerator, and the 3x squared plus 1 is in the denominator. Remind yourself, I cannot reduce the x's because this plus 1. Looking over here, GCF the denominator, GCF this, and the numerator is already set. So 6x squared, it's in a form that's already factored, so I don't have to go deeper. And down below, I can pull out a 6x squared. When I divide this term by 6x squared, I get 2x squared. And then bring down the plus. And when I divide this last term by 6x squared, I get 3. And now what reduces? All of this reduces to 1 in both of those places. Don't forget to put the 1 in the denominator or numerator. Otherwise, people forget and will often place this denominator above. Great, so we are indeed going to snowflake both the numerator and denominator. And when doing that, the numerator becomes this, x plus 2 times x plus 2. And when we snowflake the denominator, we get x plus 7 times x plus 2. Now that we have factored form, we can reduce a pair of x plus 2's. All of it. Do not reduce the x and the x and the 2 and the 2. All or nothing. And now my final answer is just to write the remainder. I do not need grouping symbols because the fraction bar is a grouping symbol. So that would be my final simplified form.
Oh, that's it.
So let's continue on the review. I want to do 2 types of multiplication/division problems with you. One is going to be monomials. What makes this monomials? I don't see a single plus or a single minus, which makes these monomials. 1. Mono means 1. Just one term, one term, one term, one term. This over here, if you look at problem number 6, This upstairs is a trinomial. This is a binomial. This is a binomial. So we're going to look at the variety of ways in which to attack, kill, and destroy these ones. This first one is we can just go straight forward and start reducing things that which reduce. Why? Because it's already all multiplication. It's all multiplication here, itang bianaki. So now I'm going to start reducing. This 5 and this 25 reduce. The 5 becomes a 1, the 25 becomes a 5. Next, this 3 and this 12 reduce, like so. Now pay attention to the magic here. All the x's. I have 4 x's there, x to the 4th, which means all 4 of these ones go away. Wait, I don't see 4. Yes, there are 3 there and 1 there. So there's that hidden 1 right there. So therefore, 3 plus the 1 will reduce all this 4. So let's see the stuff that's left over. The stuff that's left over here is I have a 4 on the top, an x squared on the top, a 5 on the top, and 1's down the bottom. So the simple answer is this, 20x squared, and that's it. So when we attack, kill, destroy problem number 6, and we're going to be factoring, we have to use all our skills for factoring. So notice for 6, the top, the numerator, I'm going to snowflake this one. I'm going to GCF this one. How do I know? Because there's not 3 terms, which usually that's when I would use a snowflake. But here I see there's an A right there, an A right there, a 4 inside there, and a 4 inside there. So I can GCF that puppy. In fact, I'm going to GCF nothing else. So I'm going to not GCF down there. I'm going to do what down here? The difference of squares. So notice in terms of our quadratics, I'm going to use all 3 of my skills. GCFing, snowflaking, difference of 2 squaring, which aren't really verbs. Okay, so let's go ahead and when you snowflake, number 6, and the top part there, you're going to get A minus 9 times A plus 2. Down below, I can pull out a 4A to get A plus 2 inside. Now, the 12 stays 12, so I'm going to leave it as so. And the denominator there is a difference of 2 squares. So I get A minus 9 times A plus 9. Remember that I'm going to get a conjugate, a pair of conjugates, when I have a difference of 2 squares. There's no work to show here. You don't need to show work here on the snowflake if you already are getting it, but you can snowflake this for those. And now, of course, the fun part, we can start to reduce. That becomes a 3, that becomes a 1, and let's see what we have left. I have a 3 in the numerator, and in the denominator, I have an A and an A plus 9. So A times A plus 9. I do not need to distribute. I can leave it in factored form. Boop, 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 and there's my answer. So when we look at problem number 8, and we look at this and we say, "Wow, it's a 4-story fraction." But really, what does a fraction mean? What does this bar mean? It just means divide. So in other words, you take this whole numerator and you divide it by this denominator. That's it.
So isn't it then just so simple?
Right, and so we can rewrite it as a multiplication. So, but I'll get to that in a second. So let's just rewrite it as a division problem. Now this step is unnecessary because you can we can convert it using KFC in a single step. But all I did was just rewrite it. So this thing itself, the whole unit, this whole unit is called a complex fraction. Not because it has complex numbers in it, because it doesn't. It's called complex fraction because it's more complicated than you're used to. Okay, so now that we have rewritten this in division form, all we have to do is KFC. So I'm going to keep the first fraction, and I'm going to flip the second fraction, actually take the reciprocal, and I'm going to change, KFC, changed. And now, of course, we can start our reduction process. One of the x plus 3's go away in the numerator. One y down below goes away, one y below upstairs goes there. And then this divides by 3, and this divides by 3. And so now let's see what's left up. In the numerator, I'm left with a 2y times y plus 3. And in the denominator, I'm left with only a 3. I do not need to reduce any further. Not only do I not need to, I can't. These 3 do not reduce. The 3's because of that plus right there. The 3's don't reduce because of that plus right there. So when we're adding or subtracting, the key thing is that we must have a common denominator before we can combine our numerators. So what are my steps to adding and subtracting? Is I need to rewrite with common denominator. We have to have a common denominator. And then second, we can combine our numerators. Combine numerators. Now, however, maybe I should have put a part 3 on there but it's maybe implied, is that we have to simplify once we're done. We always simplify if we can. Now notice number 12 already has a common denominator. That is the x plus 4's. So all I have to do is combine the common elements here. Notice that negative has to distribute. The negative needs to distribute. So when I distribute that, it can look something like this. I am just going to make that a plus, oppositify everything across. Then I can combine my like terms. The 6x minus the 5x gives me a simple 1x. Positive 4 stays positive 4. And notice what is left over the denominator, which is x plus 4. Now I'm not done yet. What can reduce here? Now here, remember when we reduce the x plus 4 reduces with the x plus 4. Not the x's, not the 4's, but all of it. So what's it reduced to? 1's. Good. Not a 0, but a 1. So now let's look at a case where we do not have common denominators, and that would be in this case here. Notice the first thing I'm going to do is I'm not deleting this. I'm factoring it and replacing it. So notice here, I can factor out a 5 there. And now, what was the process that we did here? It was all about sharing is caring. I noticed that in this over here, I have a 5 that wasn't over here in this guy. So I shared the 5 as a 1. What do I mean as a 1? Because 5 divided by 5 is 1. So when I multiply by 5 over 5, I change the form, but I don't change the value. Because multiplying by 1 stays the same. So now 5 times x plus 3 is here, and 5 times x plus 3 is here. I did not cancel this out. I'm just shorthanding the substitution. Okay, now don't reduce. We're not reducing yet. What I have to do is begin to write it as a common denominator, one denominator, and I have to combine my numerators. So 2 plus 10, or excuse me, not 2 plus 10, it's 2 plus 25. 27. Now I start to think, is there anything here that can reduce? 27 is only 3's or 9's, and I don't see a 3 or a 9 as a factor. This 3 would not reduce because of that plus. So I'm done. Stuff can be factored, but nothing can be simplified any further.